Good morning to one and all present here. In the last period, my dear students, we have started studying about the aldol condensation. To study the aldol condensation, we need to understand few things which are very important for us to be studied. Let us have a look to the kind of attack that base do on a particular carbonyl compound and what happens. So when a base actually attacks on the carbonyl compound, it generally attacks on the alpha hydrogen. So that is why we call this as a alpha hydrogen reaction. So these reactions that takes place due to the presence of the alpha hydrogen, my dear students. Now this base attacks on the alpha hydrogen, and due to the attack of the base on the alpha hydrogen, there the aldol condensation takes. The electron from this bond, I'm talking about this bond, my dear students, that the electron from this particular bond, uh, mm, the electron from this bond goes on carbon. As the electron from this bond goes on carbon, this carbon has got negative charge. And when this carbon get negative charge, as after the attack of base, we get this kind of structure where the carbon has got the negative charge. Due to this negative charge, when the electron from this negative charge goes and make a bond between these two carbon, this carbon will fill more than 4 valency, and that is why the bond between carbon and oxygen get broken and the electron goes on oxygen, and thus in the another resonance structures we'll find the negative charge present on oxygen. So now you can easily understand, my dear students, that in case of the carbonyl compound where the attack of base takes place, you can have the negative charge present on the alpha carbon. Remember, this is your alpha carbon. At the same time, you have the negative charge present on the oxygen. The negative charge present on the oxygen, as it combines with the hydrogen to give you OH, that is your hydroxyl group. At the same time, my dear students, the carbon which is an alpha carbon can attack on the another carbonyl group. Now this carbonyl group attack on the or this carbon which is an alpha carbon can attack on the carbonyl group as a nucleophile, and the carbonyl compound, the another carbonyl compound which may have slightly positive charge on carbon and slightly negative charge on oxygen due to the difference in their electronegativity, easily get this reaction done. And this is how we get from a carbonyl compound, we get an aldol product. This aldol product is the product that contain both aldehyde as well as the alcohol group, that is hydroxyl group present in them. And this is how, my dear students, the reaction moves on. So now let us revise about the aldol condensation that we have seen. You can see that whenever we try to make an aldol condensation, the the type of reaction that has to be taken place, or the type of reaction that we study, is the reaction between the two same compound. So for aldol condensation we need two same compound, and that is what.
सर
Yes, please.
मेहुल मेरिया ने ऐड करो.
Okay, sure. We need two same compounds, and as we need the same compounds, my dear students, we can easily get the uh, final product. Now, these two have, this is your alpha carbon, you can easily understand. This is your alpha carbon. Same way you have this carbonyl carbon. So when it comes to the alpha carbon and carbonyl carbon, what happens? This carbonyl carbon has got slightly positive charge. This carbon has got negative charge the resonance or due to the attack of the base. So this base actually attacks on this hydrogen. This base attacks on this hydrogen, and that is why there will be negative charge on this carbon. There will be positive charge on the carbonyl carbon, and that is why this carbon easily attacked on this. This oxygen, which is negative, which is having negative charge, takes this or takes hydrogen and it turns into the hydroxyl group here. You can easily understand. And due to this, we get a product which has both the aldehyde group and the hydroxyl group present, and that is why we call it aldol. Aldol, al represents the aldehyde group, ald represents the aldehyde group, and all represent the alcohol, and ultimately we get an aldol product by the presence of the dilute base. And this kind of reaction is known as the Aldol condensation. Here we can understand the Aldol condensation between the two ethanol molecule to get us the beta hydroxybutanol or 3 hydroxybutanol, or we can get but 2 in 1 al. Now please remember, my dear students, that as soon as you get the beta hydroxy product, that is your alcohol OH group on the beta carbon, when we heat it, the OH group from the beta carbon removes, one hydrogen from the alpha carbon removes, and we get an alpha beta unsaturated, product. So whenever you will see the final product, which is an alkene, there will be always in on second carbon. So there will be double bond on the second carbon, and if you write their IUPAC name, you will always have two in all their products. So this is how, my dear students, we understand about the aldol condensation between two ethanol. Now you can see here the aldol condensation between the two propanone or two acetone. Acetone is CS3CO CS3, my dear students. So when you want to make the attack, the carbonyl compound, so it is on positive charge. This base attacks on this hydrogen, so this carbon get negative charge. So this carbonyl carbon and negative charge alpha carbon, they combine with each other, and this CS3 has to go into the branch. So you get the aldol product, or here you get the ketone product, because this has got both the ketone as well as the hydroxyl group present. And then when you heat it, again you get the alpha beta unsaturated product. This hydroxyl group from the beta carbon and hydrogen from the alpha carbon are being removed, and that is how you get the 4-methyl 3 in 2 on. So this is how we get the product, my dear students, in case of the ketones. So please understand the type of reaction which we call it aldol condensation. Same way, my dear students, we can understand the in above both the example, we know that reactants are same and they undergo self-aldol condensation. So simple aldol condensation can also be called the self-aldol condensation. The name aldol derived from the name of two functional group, aldehyde and alcohol, and this is how we call it aldol. Aldol and ketol readily lose water and give alpha beta unsaturated product that we have discussed. Though ketones give ketones, compound containing a ketone and alcohol group, a general name aldol is kept for even the reaction between the two ketones. Now, my dear students, we want to study about the cross aldol condensation. So here we are going to study about the cross aldol condensation. The cross aldol condensation is the kind of reaction that takes place between the two different compounds. So if the reaction or if aldol reaction takes place between the two different compounds, we call such reaction, we call such aldol condensation as a cross aldol condensation. In the last period even we have studied the cross aldol condensation between the propanol and ethanol. Let us revise it well. You can see here that when there is a cross aldol condensation, we are going to get 4 products. So we want to study the cross-aldol condensation between the ethanol and propanol. So when this cross-aldol condensation takes place between the ethanol and propanol, my dear students, we shall get 4 products. Product 1, that is the self-aldol of ethanol. Product 2, that is the self-aldol of propanol. Product 3, the attack of ethanol on propanol. Remember, the attack of ethanol on propanol. And product 4, the attack of propanol on ethanol. Now, what is the thing that we need to remember is that some carbonyl compound, the carbonyl compound which that attack only from the alpha carbon. So remember that the attacker has to use its alpha carbon, and the one on which the attack takes place has to keep its carbonyl carbon free. So we will represent the carbonyl carbon in such a way that we do not show anything on the right side of the carbonyl carbon, and whatever the branch is available, we will show it under it. So this is how, my dear students, we can easily understand the attack. So first we understand the self-aldol of ethanol. We know that we get but 1R, which is also known as the crotonaldehyde. Same way, my dear students, when it comes to the self-aldol of propanol, you can see that the attack takes place from the alpha carbon. So this CH3 has to be written as a branch. Same way, on the another carbon where the attack takes place, this hydrogen has to be written as a branch, and so that we can easily explain the attack, my dear students. Again, on this alpha carbon, due to the attack of base, there is a negative charge. On this carbon, my dear students, due to the difference in the electronegativity, slight positive charge, and this positive and negative charge make the bond between the alpha carbon of one propanol and the carbonyl carbon of the another propanol, so that we can get 3 hydroxy 2 methyl pentanol. And when we heat it, there will be an unsaturation between the alpha and beta carbon, and as it is an aldehyde, you get a 2 al. That means you get the alpha beta unsaturated product. Now, my dear students, we want to study the product number 3. So that will be done on the attack of CH3CHO on CH3CH2CHO. So here the attack will take place from this carbon, that is the alpha carbon of ethanol. Same way, my dear students, the attack takes place on the carbonyl carbon of propanol. So you can see that I have written propanol as such. The attack can be done on the carbonyl carbon, and here we have written an extra H which can be attacked with the base. Now you will have the negative charge on this carbon and positive charge on carbonyl carbon, and that is why the product we get is 3 hydroxy pentanol. Again, when we heat it, there will be an unsaturation between the alpha and beta carbon, and you get pent 2 in 1 al. Same way, my dear students, in the fourth product, when there is a cross-aldol attack of propanol on ethanol, the propanol CH3 group, which is beta carbon, so the attack should be done on the alpha carbon, and that is why alpha carbon kept open in case of the propanol. There will be attack on the carbonyl carbon of the ethanol, and finally we get 3 hydroxy 2 methyl 1 butanol, and then on heating the water molecule is removed and alpha beta unsaturated product 2 methyl but 2 enol is obtained. Remember, as both these compounds are aldehyde, we have got 2 in as a product. So here, my dear students, all over when we look at the reaction, when there is a cross-aldol condensation between the ethanol and propanol, we get 4 product. From the self-aldol of ethanol, we get but-2-enol. From the self-aldol of propanol, we get 2-methyl pent 2-enol. By the attack of ethanol on propanol, we get pent 2-enol, and by the attack of propanol on ethanol, we get 2-methyl but-2-enol. This is how we get 4 products. Now, my dear students, we want to study the aldol cross-aldol condensation between an aldehyde and a ketone. So you can see that we have taken ethanol, we have taken propanone, we have taken propanone, and we have taken ethanol. This propanone attacks on the ethanol, and we get product. We shall get 4 products. So the first product, that is the product of the self aldol of ethanol, which is butenal, which is crotonaldehyde. Same day, my dear students, we have already studied this. So I'm not going to discuss it much. We have seen the self-aldol product of propanone even, which is 4-methyl pent 3-in-2 on. And now, my dear students, we are going to study the cross-aldol. So the attack of ethanol on the propanone, you can see that this is what it is going to attack. That is why we have to use this alpha carbon. So we will use this alpha carbon. This ketone, this carbonyl group will be kept open, and this has to be written as a branch. So you can see here, to show this attack, I have written the propanone in such a way that the attack can be done on the carbonyl carbon. I have made the attack from the alpha carbon of the aldehyde, and thus we get this product. Now if we give number in this way, the name of this compound we can have is 3-hydroxy 3-hydroxy butanol. This is what it is, the 3-hydroxy butanol. And when we heat it, there will be alpha beta unsaturation. So from this is your alpha carbon, this is your beta carbon. That is why alpha beta unsaturation takes place, and there will be double bond between these two carbon. And finally, you get 2-methyl but 2-in-1-al. This is how you get the final product. Same way we go for the fourth product, where the attack of propanone takes place on ethanol. So we should write, or we should keep the ethanol carbonyl carbon free for the attack, and we should do the attack by using the CH2, means alpha carbon of the acetone. So we can write it this way. We can use either of the CH3 group of the acetone, and that is why we get the same product. So you can see here on the ethanol, there will be an attack of the carbon, alpha carbon of the propanone, and due to that we get a product. We can write the, you can see we can give numbers in this way. So here we have the hydroxyl group on fourth carbon. So we should write 4-hydroxy. Total we have 5 carbon, and there is a carbonyl group on second carbon. So it is 2-pentanone, 4-hydroxy 2-pentanone we can write. And then by heating, the hydroxyl group for the fourth carbon and hydrogen from the third carbon are removed, and there will be a double bond between third and fourth carbon. So we get pent 3-in-2 on, my dear students, as a final product. So by the reaction between the ethanol and propanone, we can easily get 4 products. First, but2-enol, which is crotonaldehyde from the self-aldol of ethanol, 4-methyl, 1 pent 3-in-2 on by the self-aldol of propanone. So these are known as the self or simple or self-aldol products, whereas the two other cross-aldol products are, by the attack of ethanol on propanone, we get 3-methyl but2-in-1-al, and by the attack of propanone on ethanol, we get pent 3-in-2 on. My dear students, I would like to invite you that if you do not understand anything, you can ask me. बच्चों, कुछ ऐसा है जो आपकी समझ में नहीं आया है तो आप लोग मुझसे पूछ सकते हैं, क्योंकि ये इट इज वेरी इंपॉर्टेंट दैट यू अंडरस्टैंड दिस फिनोमेना और दिस रिएक्शन. बच्चों, आप सुन पा रहे हैं? कैन यू हियर मी?
Yes, sir.
अगर
Yes,
आपको समझ
sir.
में नहीं आया है बच्चों,
सर
कीजिए. अगर कुछ भी आपके समझ में नहीं आया है तो आप शीघ्र अभी के अभी मुझे पूछ सकते हैं. अगर आपको कुछ भी समझ में नहीं आया है, अगर आप कुछ पूछना चाहते हैं तो आप मुझसे पूछ सकते हैं. बच्चों, कुछ पूछना चाहेंगे क्या? कुछ ऐसा है जो समझ में नहीं आ रहा है? प्लीज बताइए. वी आर रिकॉर्डिंग एंड वी नीड टू मूव फॉर द फर्दर कंप्लीशन ऑफ द पीरियड इवन. बच्चों बताइए, अगर आपको कुछ पूछना है एटलीस्ट कुछ तो बोल दीजिए, सो दैट आई कैन एक्सप्लेन और वी कैन मूव फॉरवर्ड.
No, sir. No, sir.
Anyone?
No,
Nobody
sir.
wants to ask anything, okay? let's move forward and let's move to the next question. Okay, let's look at the next question. What is necessary condition for a compound to undergo aldol condensation? A carbonyl compound that has at least one alpha hydrogen can undergo aldol condensation, be it an aldehyde or a ketone. Even the presence of dilute alkali is essential. Dilute alkali is also needed, but only the compound that have the alpha carbon, they undergoes the aldol condensation. Compounds like methanol, you can see here, there is no alpha carbon, so there is no alpha hydrogen, as well as the benzaldehyde. You can see the structure of the benzaldehyde. In the structure of the benzaldehyde, where CHO group is bonded, this carbon does not possess any hydrogen. And that is why in methanol and benzaldehyde, there is no alpha hydrogen present, and that is why they cannot go self-aldol. Please remember that methanol and benzaldehyde, they cannot undergo self-aldol condensation. Now, when it comes to the cross-aldol, my dear students, and in cross-aldol we get 4 products. But when it comes to the cross-aldol, and if the benzaldehyde or methanol are present, they will undergo the attack from the another compound, and that in that cases we will get 2 products if one of the compound is methanol or benzaldehyde. First product is the self-aldol of the compound that has got the alpha hydrogen, and second product is the product where the compound with the alpha hydrogen will attack on either methanol or methanol or benzaldehyde, and we get the product. So but an aldehyde or ketone with alpha hydrogen can give aldol reaction with them, and that is why we can have the cross aldol products uh, obtained from the methanol or benzaldehyde. But please remember, the benzaldehyde or methanol, they cannot give, or they do not give the self-aldol condensation. With example, explain the aldol or cross-aldol reaction between ethanol and benzaldehyde, propanol and methanol, and methanol and ethanol. So here, my dear students, we are not going to discuss the self-aldol reaction, but we are just going to discuss the cross-aldol reaction that takes place between the ethanol and benzaldehyde. So please pay attention. This is your ethanol. Here the ethanol can attack because it has got the alpha hydrogen present, where the base can come and attack on the alpha hydrogen, so that there will be a negative charge on the carbon, or on the alpha hydrogen carbon, we can say, and there will be a slight positive charge between the difference of the electronegativity of carbon and oxygen, and thus the attack from the alpha carbon of ethanol takes place on the benzaldehyde, and we get 3-hydroxy 3-phenyl propanol. Now again, when we heat it, my dear students, this is the alpha carbon, this is the beta carbon. The hydroxyl group from here and hydrogen from here can be removed, and we can get a product where benzene ring is bonded to the CH double bond CH CHO. This compound is known as cinnamaldehyde. Please remember that this compound is known as cinnamaldehyde, and the IUPAC name for cinnamaldehyde is 3-phenyl. On third carbon there is phenyl group. The priority is given to the carbon which is present into the aldehyde group or functional group. So it is 3-phenyl prop 2-enol. Same way, my dear students, we can understand the cross-aldol between the propanol and methanol. So here you have propanol, which is CH3, COCH3. Your methanol is HCOOH. There the alpha carbon attacks on the carbonyl carbon of the methanol, and finally we get 4-hydroxy 2-butanol. This 4-hydroxy 2-butanol, when it is heated, my dear students, the hydroxyl group present on 4th carbon and the hydrogen on the 3rd carbon is being removed, and there will be double bond between the 3rd and 4th carbon. So you can see here 1, 2, 3, 4. There is a double bond between the 3rd and 4th carbon. So we get the final product but3-in-2-on as a product. Same way, my dear students, when we understand the reaction or a cross-aldol condensation between the methanol and ethanol. You can see this is your methanol, HCHO. Here we have the ethanol which has got the alpha carbon. So you can understand the presence of the alpha carbon here. This alpha carbon has alpha hydrogen which is attacked by the base, and as this base attacked on this hydrogen, there will be negative charge on this carbon which can attack the positively charged carbonyl carbon due to the difference of electronegativity, and ultimately we get 3 hydroxy propanol. Again you have 1, 2 and 3 carbon. When we heat it, the hydroxyl group from the third carbon and 1 hydrogen from the second carbon moves on, and we get prop 2 in 1 al, which is also known as the acrolein, my dear students. So please remember the product, their common name, because sometimes you may be asked the question based on their common names. So please remember these names like acrolein, crotonaldehyde, cinnamaldehyde, which are already discussed while we have been discussing while we have been discussing the nomenclature. And please remember these names, because from these names even you may be asked the question either in your CBSE exam or in your competitive exams. Now, my dear students, we are going to study about one more name reaction, which is known as the Cannizaro reactions. So please, if you have any doubt regarding your aldol condensation or cross aldol condensation, immediately ask me now, or else we can move to the Cannizaro reaction. This is the very important reaction, and I can assure you that in most of the cases you will get at least one question based on the aldol or cross aldol, or it may be from the Cannizaro reactions. Should we move forward, or do you want to have something to ask, my dear students? Please reply.
Nothing to ask.
Okay. Thank you for your response, and I would like all of you to respond this way, my dear students. Uh, let's move forward and try to understand the Cannizaro reaction. Aldehydes, which do not have an alpha hydrogen atom, undergoes self-oxidation and reduction. So once the oxidation takes place, another time the reduction takes place from the same compound. That is what it is, the reaction which we call it disproportionation reaction. On heating with the concentrated alkali. Please remember that in the aldol condensation, we have used the dilute alkali, but here in Cannizaro reaction, we use the concentrated alkali. Such reaction is called Cannizaro reaction. So remember, those compounds which do not have alpha hydrogen or they do not have alpha carbon, they give this Cannizaro reaction. That means methanol and benzaldehyde are definitely going to give the Cannizaro reaction. So we will study their Cannizaro reaction. During the Cannizaro reaction, my dear students, this methanol or benzaldehyde, once they are oxidized, another time they are reduced, and that is why this kind of reaction is a reaction where the disproportionation takes place. And ultimately, when the disproportionation takes place, methanol, when it is reduced, it gives methanol, and when it is methanol, when it is oxidized, in the presence of strong alkali, concentrated alkali, we get the sodium or potassium salt or the metal salt of the carboxylic acid. So let us study the reaction in detail. If we study it for the methanol, my dear students, you can see that two methanol molecules, they react with each other. As these two methanol molecules react with each other in the presence of concentrated KOH, one methanol undergoes the reduction so that we get alcohol, that is your methanol, and on oxidation it gives carboxylic acid, but it gives the potassium salt of carboxylic acid, and you get potassium formate, because methanol is also known as the formaldehyde, and and methanoic acid is also known as the formic acid, and that is why the potassium salt of formic acid is known as the potassium formate. You can even write potassium methanoate. Same way, my dear students, when we have the benzaldehyde, two benzaldehyde molecules undergoes the reaction in the presence of the concentrated alkali, that is concentrated sodium hydroxide, and thus we get benzyl alcohol by the reduction of benzaldehyde. and we get sodium benzoate by the oxidation of the benzaldehyde, and this is how the disproportionation reaction takes place. Once the benzaldehyde goes oxidation, another time the benzaldehyde goes the reduction, and this is how, my dear students, we understand about the Cannizaro reaction. Today we understood a very two important reaction. One is aldol, another is cross aldol, and then we have studied about the Cannizaro reaction. Now, my dear students, we need to understand about the electrophilic substitution reaction given by these aldehydes and ketones. We know that aldehydes and ketones, they have the carbonyl carbon present in them. Generally, the compound, or if the benzene ring is bonded with the carbonyl carbon, it becomes the meta directing in nature, and that is why whenever there is electrophilic substitution reaction takes place on benzene ring, we generally get the meta substituted product. The various electrophilic substitution reactions that we study are either the nitration, my dear students, or it may be halogenation, or it may be sulfonation, please remember, or it may be Fiedel-Crafts, either it may be alkylation or it may be acylation that we see, my dear students. So in all these cases, if we let this go undergo the substitution reaction, it generally gives the meta product. And when benzaldehyde undergoes the electrophilic substitution reaction, which is known as the nitration, in the presence of nitric acid and sulfuric acid at 273 to 283 Kelvin, we get meta-nitrobenzaldehyde, my dear students. Now we have few more questions to undergo. So this is how I can do the assessment. Arrange the following compounds in the increasing order of their reactivity in nucleophilic addition reaction. My dear students, we have already studied that for the nucleophilic addition reaction, the aldehydes are more reactive as compared to the ketones. So you can see here that ethanol, which is an aldehyde, propanol, which is an aldehyde, propanone, which is a ketone, butanone, which is a ketone. The more number of carbon bonded to the carbonyl group will decreases its nucleophilicity, and that is why we can say that butanone will be least reactive, whereas the ethanol is the most reactive, and that is why we can arrange them in the increasing order as such. Butanone is less reactive than propanone. Propanone is less reactive than the aldehyde propanol, and propanol is less reactive than the aldehyde ethanol, because ethanol has got only one carbon bonded to the carbonyl group. But in case of the propanol, there are two carbon bonded. In case of the propanone, there will be two carbon bonded at both the side, but it can, in case of the butanone, we will have four carbon bonded to this side, so they increase the electron density on carbon, and thus the positivity of carbon is being decreased, and that is why they are that is why this butanone is less reactive towards the nucleophilic addition reaction. Same way, my dear students, here we have benzaldehyde, which has phenyl group and aldehyde. We have para-toluene, which have methyl group, which is an electron donating group, and with the aldehyde. Same way, we have para-nitrobenzaldehyde. Nitro group is electron withdrawing group, and we have acetophenone, which has uh, carbon bonded to both the side of carbon. So this is ketone, this is aldehyde, this is aldehyde, and this is even aldehyde. In this aldehyde, this is the pure benzaldehyde. Here in the benzaldehyde, you have methyl group, which is electron donating group present. Here the nitro group which is present, which uh, remove the electron, or which is electron withdrawing group. And that is why, my dear students, this nitro group will be more making the carbon of the carbonyl carbon more electropositive, whereas the methyl group which is present in the carbon will make the carbonyl carbon less electropositive. Acetophenone, being ketone, will be less reactive than the aldehydes, and that is why acetophenone is the least reactive among all. Then it comes to the para-aldehyde, because the methyl group which decreases the nucleophilicity, methyl group decreases the positive charge on carbonyl carbon, benzaldehyde and nitro group increases the uh, positive charge on carbonyl carbon because nitro group is the electron withdrawing group. So this is how, my dear students, we can easily study about the various electrophilic effect on the, and we can arrange the various compounds on the increasing order. Now we have the next question, predict the products of the following reaction. So here we have a ketone, and this ketone is going to react with the hydroxylamine. You know that, my dear students, the oxygen will be removed and there will be a double bond between this carbon and hydrogen. And these two hydrogen will also be removed from the amine, and that is how this nitrogen combines with this carbon, and there will be double bond between this carbon and nitrogen, and this is how we get the product. Same way, my dear students, here even we can understand that this nitrogen going to combine with this carbon, the two hydrogen present on this nitrogen will be removed, this oxygen will be removed from the uh, carbonyl compound, and then there will be double bond between this carbon and nitrogen, and this is how we are going to get the final product. Same way, my dear students, this is what we have studied about the addition of the ammonia and its derivative to the carbonyl compound. You can see there is an unsaturation here, but here we have the carbonyl compound present. This carbonyl compound, my dear students, simply combine with this nitrogen with the double bond. So here there will be a double bond between this carbon and nitrogen. This oxygen will be removed. This hydrogen, two hydrogen from the remove. So by the condensation, one water molecule is removed and there will be double bond between this carbon and nitrogen, and we get the final product as an oxygen. Uh, this is, my dear students, the final product, that is what we get it here as an oxygen. Same way, my dear, this is urea, but this is, here you can see a ketone present here, my dear students. This ketones reacts with the primary amine. Here you have the primary amine.